Now, hopefully, you're starting to see a pattern here on these perfect square trinomials. Okay. The pattern is, if it's a perfect square trinomial, the c value, if you have in the form ax squared plus bx plus c, which all our trinomials are, okay, the c value is half of the b value squared. So everybody, make sure you got a big old box around this. This is important. This is what we're doing for the rest of this video. Okay, b over 2 quantity squared. Okay, and these are the 4 problems that we just did right here. And I told you they were all perfect trinomial squares. But look at the pattern here. Okay, just remember this is a, b, c. Okay, if it's true, if these really were all trinomial squares, they should have this pattern where c is half of b, half of negative 8 is negative 4, quantity squared, positive 16, and it is. And over here, okay, this 9, it should be half of 6, which is 3, quantity squared, that's 9. Okay, so it was a perfect trinomial square. All these problems should be. Okay, we divide this one by 2, that's negative 5, quantity squared, that's positive 25. Looky there. Okay, and this pattern reoccurs in all perfect trinomial squares. Half of negative 24 is negative 12. Quantity squared is positive 144. Okay, and this is a huge concept, okay? Something we really need to know how to do. It'll help you solve a lot of equations in the future. Okay, but just to show you, all those perfect trinomial squares, they all have the same pattern. It's b divided by 2, quantity squared. Okay, so let's make our own perfect trinomial square. Okay, after you made it, I want you to factor the expression. Okay, x squared plus 14x plus c. Now we need to figure out what c is to make this expression a perfect trinomial square. And I showed you the pattern. C should always be b divided by 2 quantity squared. So if my b value is 14, 14 divided by 2 quantity squared. 14 and 2 cancel, that leaves me a 7 squared, and there's a reason I'm showing my work. This is actually going to be a really important number when we get into fractions. Okay, that equals 49. Okay, and so what we're going to do is we're going to say x squared plus 14x plus 49 should be a perfect square trinomial. So let's factor it. Let's see. X plus 7 quantity squared. There's our factored term. Okay, now the number I put in the box right here. Okay, you need to show your work for this number. Okay, if you reduced a fraction or if you squared a fraction or whatever you did, divided it by 2, that number is important because it will always be the number in the parenthesis of your factored term. Okay, I really want to stress that that's important because when we do get odd numbers or when we do get crazy numbers, okay, that'll save you a lot of time and headaches. All right, so let's look at another one here. Once again, I want this to be a perfect trinomial square, so I had to figure out a number to add on here that's going to make it a perfect trinomial square. Well, we looked at the pattern before and we said b divided by 2 quantity squared has to be the last value if it's going to be a perfect trinomial square. So I know my b value is negative 10. I'm going to divide it by 2. I'm going to square that quantity. Now the reason I'm writing this negative 5 in here is because I'm going to use this negative 5 later. Okay, my c value actually is going to be negative 5 squared, which is 25. So x squared minus 10x plus 25. Okay, and you should always have a plus right here, the second one. It's always a plus. Okay, so let's take a look here. I know that half of negative 10 is negative 5, quantity squared is 25. Okay, that's where I got my 25. My factored term, if I want to factor this, is x minus 5 quantity squared. And once again, I'm going to stress this. This negative 5, before you square it, is the thing that's going to end up in the parentheses. Okay, so on your paper, I need to see this guy and this guy. All right, I highly, highly, highly recommend you show your work for this step so you know what's going to be in that parenthesis later. Okay, let's look at another one here. Okay, once again, I have this perfect trinomial square. I want it to be a perfect trinomial square, so I need a number for c. The pattern is it's half of the b value, quantity squared. Just take 22 divided by 2, quantity squared. That's 11 squared, and I'm going to keep this value in mind because 11 squared is 121, and that's the actual c value. X squared plus 22x plus 121. Okay, so my C value is 121. That makes this a perfect square trinomial. But I already know what I'm going to factor it into because this 11 is going to come right down here. It's a plus plus this time, so I'm going to say x plus 11 quantity squared. I need this guy. I need this guy in my paper. Those aren't plus minuses. That's just, I underline those. All right, x plus 11 quantity squared. So now I'll give you an example here of one that might not work out so pretty. However, you do need to know how to do it because we're going to do this a lot. Okay. So this time, the problem is this little guy right here is an odd number, which does not make things fun, because what's going to happen is we're going to have a little fraction for C. Okay, so let's take a look here. I need half to make this a perfect trinomial square, I need half the B value quantity squared. 9 divided by 2, quantity squared. Okay, and there's no first reduction here. So this is the guy that's actually going to go in the parentheses. Okay, that makes 81 over 4. So my C value is actually 81 over 4. So as you can see, now that we have a perfect trinomial square, we can factor it. We can factor this is actually a perfect square trinomial. We can say x plus 9/2 quantity squared. Okay, and if you don't believe me, let's just do a little work here to check our answer. X plus 9/2 times x plus 9/2. X times x is x squared. X times 9/2 is plus 9/2 x. 9/2 times x, another plus 9/2 x. And then 9/2 times 9/2 is 81/4. And looky there, x squared plus 18/2, which is really, everybody, 9. X plus 81/4. And look, we did get our original, what we said the equation should be. All right, so the pattern for any perfect trinomial square is half of the B value squared. If that's the dead giveaway, if it's a perfect trinomial square, as long as there's no number in front of x squared, that's your giveaway. Okay, no, there's not a number there, you're in good shape.